Have you ever tried to imagine a day when the sun, that familiar glowing orb in our sky, begins to change, to grow unpredictable, and the Earth we know and cherish no longer exists as it does today? It's a question so vast that it feels almost impossible to grasp. Yet it's the starting point for our journey into the distant future. 5 billion years from now. That is the time span we are about to explore, a stretch of time so immense and so far beyond human experience that it challenges our very ability to comprehend. 5 billion years is more than just a number. It's a scale of time that dwarfs our everyday sense of past and future. To put this in perspective, think about the average human lifespan, say roughly 80 years. Now multiply that by 62.5 million. That's how many human lifetimes would fit into 5 billion years. Another way to look at it is through the lens of history-recorded human history spans, approximately 5,000 years, a blink of an eye compared to this gargantuan span. Imagine compressing everything we know, our civilizations, our achievements, all of human culture into a single grain of sand. And then think about the entire expanse of 5 billion years as a desert stretching endlessly in every direction. It's no wonder we struggle to hold such a concept in our minds. Even the history of our planet itself, Earth, feels small in comparison. Our planet is about 4.5 billion years old, meaning the stretch of time we are discussing surpasses the entire age of Earth. So when we talk about what life might look like 5 billion years from now, we are speculating on a future that outlasts the entire story of our planet's birth and transformation. We are venturing into an era beyond the familiar, beyond what life as we know it has ever witnessed. This makes the question incredibly humbling. Will life still exist at all, or will it vanish like a brief spark fading into the darkness? When the idea of 5 billion years sinks in, it invites not only awe, but also a deep sense of mystery. What kind of changes could take place in such an almost unimaginable stretch of time? Our minds naturally race to science fiction, imagining sprawling space empires or immortal beings. Yet the real scientific story is no less astonishing, and in many ways even more profound, because it is grounded in the natural processes of our universe. The key to unlocking this mystery lies with the sun, the colossal furnace at the center of our solar system, the star that has fueled life on Earth since its formation. The sun's future is directly tied to the future of life on Earth. It is the engine that drives the cycles of seasons, the warmth that nurtures every living thing. But this engine, powerful as it is, will not burn forever. Like all stars, the sun has a lifespan, and it is slowly running out of fuel. This is where the story of the next 5 billion years begins. The sun, now a middle-aged star at about 4.6 billion years old, is destined to undergo dramatic transformations that will ultimately reshape the solar system and make Earth an alien, inhospitable world. Trying to envision these cosmic changes is like staring at a tapestry being slowly unraveled, thread by thread, the pattern changing beyond recognition. At some point in the distant future, the sun will swell into a red giant, growing so large that its outer layers will likely engulf the inner planets, including Earth. The Earth we know, with its blue oceans, thriving ecosystems, and bustling human civilizations, will be utterly transformed if it still exists at all. These are not just abstract predictions. They are grounded in decades of astrophysical research, telescopic observations, and the laws of physics that govern all matter and energy. So what happens to life in the face of such monumental change? Will it cling on, adapting in ways we can barely imagine, or will it fade away with the dying light of our star? This question is at the heart of our exploration. Life on Earth has proven remarkably resilient, having survived mass extinctions and cataclysmic events. Yet the scale of the sun's eventual transformation poses a challenge like no other. Some scientists speculate that life might migrate perhaps to distant moons, to planets beyond our solar system, or even aboard spacecrafts traveling to new worlds. Others suggest that life might evolve beyond biology, transcending physical form altogether. As we stand at this crossroads of imagination and science, it becomes clear that understanding the sun's life cycle is the gateway to answering where life will go in the next 5 billion years. The story of our star is not just about destruction. It is about change, evolution, and the possibility of new beginnings. It challenges us to think beyond our brief human timescale and consider a future shaped by forces far larger than ourselves. Before we delve deeper into this cosmic saga, let us take a moment to appreciate the incredible scale of time and space we are about to traverse. The 5 billion years ahead represent more than just a distant future. They represent the ultimate test of life's endurance, creativity, and capacity for transformation. So let's begin this journey by turning our gaze to the past and future of the sun, the colossal lantern in our sky, whose fate will ultimately determine the destiny of life on Earth, and perhaps beyond. The sun's story is the first chapter in the epic tale of life's long voyage through the cosmos, a voyage that beckons us to imagine, to wonder, and to question our place in the grand unfolding of time. The fire burning deep within the sun is a paradox of existence, unrelenting and fierce, yet destined to one day flicker out. This blazing heart of our solar system has been shining steadily for billions of years, fueling the life that thrives on Earth and orchestrating the rhythms of our planet. But despite its seeming permanence, the sun's fire is not eternal. The truth is, the life of a star like our sun is a brilliant, beautiful story of both creation and inevitable decline. Understanding this stellar lifespan is key to unlocking the fate of life here on Earth. Why does the sun's life cycle matter so much for life on our planet? At its core, the sun is the engine that makes Earth habitable. Its warmth enables water to exist in liquid form, powers photosynthesis in plants, and regulates the climate systems that sustain ecosystems. Without the sun's energy, Earth would be a frozen rock drifting silently in space, devoid of life. But stars, like all things in nature, have beginnings, middles, and ends. The sun is currently in the middle of its life, a phase astronomers call the main sequence. During this stage, the sun fuses hydrogen atoms into helium in its core, releasing energy that travels outward and bathes the solar system in light and heat. This phase, while stable, is not permanent. The sun has been burning hydrogen for about 4.6 billion years and is expected to continue doing so for another 5 billion years or so. Eventually, the hydrogen fuel in its core will start to run low, triggering profound changes in the star's structure and behavior. The core will contract under gravity, heating up until it ignites helium fusion. Meanwhile, the outer layers of the sun will expand dramatically, turning our star into what astronomers call a red giant. This transformation from a relatively compact yellow dwarf to a vast red giant is nothing short of cosmic theatre. The sun will balloon to a size so large that it could engulf the orbits of Mercury and Venus, and possibly even Earth. Imagine the night sky becoming dominated by a fiery red disk growing larger and hotter each year. This isn't science fiction. It's the natural destiny of stars like ours. This swelling will not only increase the sun's brightness, bathing Earth in scorching heat, but the very structure of the solar system will be reshaped. What does this mean for our planet Earth? Will face extreme conditions that challenge the survival of all life as we know it. The increasing heat will cause the oceans to evaporate, the atmosphere to strip away, and the surface to become inhospitable. It is a future where familiar landscapes will wither and life will either be forced to adapt or perish. But could life find a way to endure such a radical transformation? The resilience of life on Earth is legendary, surviving ice ages, asteroid impacts, and mass extinctions. So might it adapt to this fiery new reality? Could some form of life migrate deeper underground into the ocean's depths, or evolve new biological mechanisms to withstand the extreme heat? Beyond biological adaptation, there is also the possibility of migration, moving life away from Earth itself. As the sun swells, the habitable zone, the Goldilocks zone where temperatures allow liquid water, will shift outward. Planets and moons farther from the sun, such as Mars or the icy moons of Jupiter and Saturn, might enter this new habitable region. This raises the intriguing question: could life hitch a ride to these new frontiers? Perhaps future civilizations or even robotic explorers carrying the seeds of life might seed these distant worlds to ensure survival beyond Earth's decline. But even with these possibilities, the challenge remains daunting. The expansion of the Sun and its eventual shedding of outer layers will alter the entire solar system's architecture. After the red giant phase, the Sun will blow off its outer shell, creating a magnificent planetary nebula, a glowing shell of gas and dust. What remains at the core will be a white dwarf, an incredibly dense and slowly cooling remnant of the Sun's former glory. This white dwarf will no longer generate energy through fusion, instead radiating away its stored heat for billions of years to come. The Sun, the source of all life on Earth, will become a cold ember in the vast darkness of space. The fate of Earth during these final stages is still a topic of scientific debate. Will it be engulfed and destroyed, or will it survive as a scorched, lifeless rock orbiting a fading star? Either way, the Earth we know will be irrevocably changed, and the familiar cradle of life will likely no longer exist. This stark future prompts a profound reflection on the fragility and transience of life itself. Yet the death of the Sun is not simply an end, it is a transformation, a phase in the ongoing cosmic cycle of birth, death, and rebirth. The materials expelled during the Sun's final outbursts will enrich the surrounding space with heavy elements, the building blocks for new stars, planets, and possibly new life. The universe, ever cyclical, recycles and renews itself, weaving new stories from the remnants of the old. As we contemplate the Sun's fiery destiny, we confront the grand question: if Earth becomes uninhabitable, if our home is consumed or rendered lifeless, where will life go next? Is there a way for life to survive? Not just decades or centuries, but billions of years. The answer lies in exploring not only the fate of Earth, but the broader solar system itself and beyond. This leads us to the next phase of our exploration, considering where life might find refuge if Earth is no longer a sanctuary. Could other worlds in our solar neighborhood harbor life in the far future? Could humanity or its descendants establish new homes among the stars? The Sun's fire, while ultimately destructive, also ignites the spark of imagination and hope for life's enduring journey. So as we leave behind the Sun's fiery transformation, let us turn our gaze outward to the planets and moons that orbit this great star, searching for signs of future habitability and possibilities of survival. The story of life in the next 5 billion years depends not only on the Sun's fate, but on the courage and creativity of life itself to seek out new horizons. Have you ever thought that life is bound only to Earth, that the rich tapestry of existence is woven exclusively on this pale blue dot? Now imagine that life breaks free from its earthly cradle and ventures boldly into the vastness of space, seeking new homes among the stars and moons of our solar system. This idea, the cosmic migration of life, might sound like a dream born of science fiction, but it is increasingly becoming a subject of serious scientific inquiry and hopeful speculation. The concept of life spreading beyond Earth is rooted in both necessity and possibility. As the Sun ages and changes, Earth's ability to sustain life will inevitably decline. This forces us to ask, where else might life find sanctuary? The solar system is not just a collection of barren rocks. It is a dynamic, complex neighborhood filled with worlds that, under the right conditions, might harbor life, or at least support it in some form. From the dusty plains of Mars to the icy hidden oceans beneath the frozen crusts of moons like Europa and Enceladus, these places present tantalizing opportunities for life's persistence beyond our home planet. Mars, the red planet, has been a prime candidate in the search for extraterrestrial life for decades. Its surface today is harsh, thin atmosphere, frigid temperatures, and relentless radiation. But evidence suggests that ancient Mars once had flowing rivers, lakes, and perhaps even shallow seas. Scientists believe that beneath its dusty exterior, Mars might still possess subsurface ice, or even liquid water trapped beneath layers of rock and soil. This raises the possibility that microbial life, if it ever existed, could survive in hidden refuges beneath the Martian surface. The idea that humans might one day colonize Mars is no longer a distant fantasy. Space agencies and private companies alike are developing technologies to send astronauts and eventually settlers to Mars, hoping to establish a foothold for life beyond Earth. These efforts include building habitats capable of shielding inhabitants from radiation, generating water from ice, and growing food in controlled environments. But Mars is only one chapter in this story of cosmic migration. Farther out around the giant planets, Jupiter and Saturn lie icy moons with subsurface oceans that could be more hospitable than their frozen exteriors suggest. Europa. One of Jupiter's moons has an ocean beneath a thick layer of ice kept liquid by tidal, heating the gravitational pull of Jupiter, flexing Europa's interior like a cosmic muscle. This hidden ocean may contain the necessary ingredients for life, water, energy, and organic molecules. Similarly, Saturn's moon Enceladus has been found to eject plumes of water vapor and organic compounds from fissures in its icy crust, indicating an active ocean beneath its surface. These moons might host environments where life could survive or even thrive in forms radically different from anything on Earth. The possibility that life could exist or be introduced on these worlds sparks questions that stretch from science into philosophy and ethics. Could life adapt to such alien environments? Could terrestrial life survive transplantation? Or might it evolve anew under these extreme conditions? Efforts to understand these possibilities are driving some of the most exciting missions in space. Exploration today, such as the Europa Clipper mission, set to explore Jupiter's moon in unprecedented detail, and proposals to send probes to Enceladus to analyze its plumes. Yet the challenges are immense. The environments are not just cold and dark. They are hostile in every imaginable way compared to Earth's life-friendly habitats. Life on Earth is incredibly versatile, but surviving the intense radiation on Mars's surface or thriving in the crushing depths beneath Europa's ice demands forms of resilience and adaptation that push biological limits. The question of whether life can find a new home among these distant worlds is as much about biology as it is about human ingenuity and technological advancement. Humanity's own attempts at space colonization offer a microcosm of this cosmic migration. Building sustainable habitats off Earth means replicating or compensating for Earth's life-supporting systems. From artificial atmospheres to hydroponic gardens, from radiation shields to closed-loop ecosystems, these endeavors reflect our yearning to extend life's reach. They embody hope that even if Earth's future becomes uncertain, life might continue evolving and adapting far beyond the familiar. Still, this hope must be balanced by realism. While these efforts are promising, the vast distances, harsh conditions, and technological hurdles remain daunting. The era of interplanetary migration, if it comes, is likely centuries away, and will require breakthroughs not only in engineering, but in our understanding of biology, psychology, and society. Moreover, there are ethical questions about contaminating pristine environments or displacing potential native ecosystems. If life on Earth can find new homes within the solar system, it would mark the beginning of a profound new chapter, a cosmic diaspora, where life spreads outward, driven by both necessity and curiosity. This vision opens up possibilities that challenge our sense of place in the universe and invite us to reconsider what it means to be alive, to belong, and to survive. But what if the solar system itself becomes inhospitable? What if even the most promising new homes fail to sustain life in the long term? If Earth and its neighbors can no longer harbor life, could life journey even farther? Could it cross the interstellar void, traveling to distant star systems where conditions might be more favorable? These questions propel us beyond the confines of our solar neighborhood into the broader cosmos, a vast, mysterious ocean of stars and planets yet to be explored. This next frontier may hold the ultimate refuge for life's persistence, but the challenges it poses dwarf those within our solar system. To contemplate this possibility is to step into the unknown, fueled by a mixture of science imagination and the enduring human spirit to survive and explore. The journey of life, then, is not simply a story of origins, but also of voyages of adaptation, migration, and transformation across unimaginable distances and timescales. As we ponder the future of life in the next 5 billion years, we find ourselves standing at the edge of a cosmic crossroads, where the fate of life depends on both the fiery transformations of our star and the boundless potential of life to seek new horizons. With this in mind, we turn our attention to what lies beyond. How far can life truly travel, and what forms might it take as it ventures into the interstellar abyss? In a universe so vast, sprinkled with countless stars and potentially habitable planets, one question presses upon our minds with unsettling urgency: why haven't we found anyone else? This conundrum, known as the Fermi paradox, confronts us with a profound mystery. If the cosmos is teeming with the raw ingredients for life, and if life itself has the remarkable ability to spread and adapt, then where is everyone else? Why does the silence of the stars feel so deafening? The Fermi paradox is named after the physicist Enrico Fermi, who famously posed the question during a casual conversation: where is everybody? His question echoed a deep contradiction. On the one hand, the sheer number of stars in our galaxy alone, many hosting planets in their habitable zones, suggests that life, and possibly intelligent civilizations, should be abundant. On the other hand, despite decades of searching for signals or signs of extraterrestrial intelligence, the universe remains eerily quiet. No confirmed contact, no clear evidence, no unmistakable footprints left in the cosmic dust. This silence is as puzzling as it is profound. To grapple with this paradox, scientists and thinkers have proposed a wide range of hypotheses. One possibility is that life, particularly intelligent life, is exceedingly rare. The conditions that allow life to begin to evolve complexity and to develop technology capable of interstellar communication or travel may be so improbable that Earth is a unique or nearly unique oasis in the galaxy. Another possibility is that intelligent civilizations tend to self-destruct, whether through nuclear war, environmental collapse, or unintended consequences of their own technological advancements. Many civilizations might burn brightly and then fade away before ever reaching out into the cosmos. There are also ideas that civilizations might exist but deliberately avoid contact, practicing some form of cosmic quarantine or zoo hypothesis, allowing less advanced species like ours to evolve without interference. Alternatively, advanced civilizations might exist in forms that are difficult or impossible for us to detect using technologies beyond our current understanding or communicating in ways we cannot yet perceive. This tangled web of possibilities forces us to confront a sobering reality. The survival of intelligent life may not be a given, but rather a precarious balance fraught with internal risks and external threats. The Fermi paradox implicitly challenges the idea that life once born will naturally thrive and spread endlessly. Instead, it suggests that life's long-term existence may be limited by factors intrinsic to its nature or environment. It invites us to ask uncomfortable questions about the future of life on Earth. Are we following a path that leads inevitably to extinction? Or can we learn to navigate the perils that have silenced other civilizations if they ever existed? Yet the paradox also opens the door to more hopeful and imaginative ideas. Perhaps life is indeed out there, but in ways that defy our expectations. Maybe other forms of life have chosen or been forced into hiding, cloaking themselves from detection, or evolving into states of existence beyond our comprehension. Could there be civilizations that have transcended physical forms, existing as vast networks of consciousness or digital minds scattered through the galaxy? Might they be communicating on frequencies or dimensions that remain invisible to us? Such thoughts stretch the boundaries of our understanding and urge us to expand our search beyond conventional methods. They also remind us that our place in the cosmos might be stranger and more complex than we imagine. The silence we perceive might not be absence, but a veil waiting to be lifted by new discoveries or new ways of thinking. As we grapple with this paradox, we are drawn deeper into the question of life's resilience and adaptability on cosmic scales. If the future of life is not just about survival on Earth, or even within the solar system, but about thriving amid the vast, mysterious expanse of space, how might life reinvent itself? How might it hide, evolve, or communicate in ways that challenge our very notions of existence? This line of thinking naturally leads us toward exploring other possibilities, the hidden, the unusual, the unexpected. It invites us to consider that life might not always shine brightly like our sun, but could flicker softly or lurk unseen, waiting for us to recognize its subtle signs. From here, we embark on a journey to uncover those mysteries, to look beyond the obvious, and to imagine the diverse and surprising forms that life might take as it endures in the cosmos. What if instead of being alone or abandoned in the vast cosmic wilderness, we are actually part of an elaborate interstellar menagerie? The idea that we might be living in a kind of cosmic zoo, quietly observed by more advanced civilizations, is both unsettling and strangely comforting. It suggests that far from being ignored or forgotten, Earth's life might be under the careful watch of beings whose motives and technologies surpass anything we can yet imagine. This concept, known as the zoo hypothesis, proposes that advanced extraterrestrial civilizations deliberately avoid direct contact with humanity to allow for natural development, much like zoologists observe animals in a preserve without disturbing their behavior. The premise is that these civilizations are aware of us, have the means to reach us, and perhaps even visit or study our planet covertly, yet choose to maintain a respectful distance, preserving the natural course of our evolution and cultural growth. The reasons behind such restraint might be ethical, scientific, or strategic. For example, they might see us as too primitive to engage with directly, fearing that premature contact could disrupt or harm our society. Alternatively, they could be bound by some form of interstellar protocol or moral code that values non-interference with emerging civilizations. In this light, Earth becomes less of a lonely outpost in the cosmos and more of a carefully tended exhibit in a grander scheme. The implications of this hypothesis ripple far beyond simple curiosity. It reframes our understanding of our place in the universe, suggesting that we might be part of a larger network of life, interconnected yet separated by boundaries we have yet to comprehend. This perspective also challenges us to reconsider our assumptions about progress, intelligence, and civilization. The silence we perceive may not be emptiness, but a deliberate quietude imposed by those who watch us. If the zoo hypothesis holds any truth, it forces a humbling reckoning. We are no longer the architects of our destiny alone, but potentially subjects of observation and study. Our technological milestones, cultural achievements, and even existential struggles could be catalogued and analyzed by watchers beyond the stars. Such a scenario invites profound questions. What responsibilities come with being observed? Does this surveillance influence our development? Could it offer a hidden form of protection or guidance subtle enough to avoid detection, yet potent in shaping our trajectory? Moreover, this hypothesis opens the door to the possibility that the universe is filled with many such zoos, each hosting life at various stages of complexity and development. Perhaps countless civilizations are observing one another, maintaining their own codes of conduct regarding interaction and interference. This paints the cosmos as a grand theater where life unfolds under the watchful eyes of unseen audiences, each act governed by rules we have yet to decipher. Yet the zoo hypothesis also pushes us to think beyond our terrestrial definitions of life and civilization. If advanced beings are watching us, they might themselves have evolved beyond biological forms or communicate in ways utterly foreign to us. Their interests and methods could be so alien that their presence remains undetectable to our current technologies and understanding. We might be like ants, unaware of the distant observer studying their colony, their presence masked by layers of complexity and difference. This leads us to a broader and even more speculative question. What forms might life take elsewhere? If the universe harbors watchers, might it also host life so different from our own that we would not recognize it as life at all? Could life exist as patterns of energy, networks of information, or in dimensions beyond our perception? Such possibilities stretch the imagination and scientific inquiry, compelling us to expand our search parameters and rethink the very essence of what it means to be alive. Contemplating the zoo hypothesis thus becomes a gateway to reimagining life's potential diversity and resilience. It nudges us to look not only for carbon-based organisms on distant planets, but to consider entirely new modes of existence. Perhaps the future of life, ours and others, is not merely survival or expansion, but transformation into something unrecognizable, yet vibrant. As we ponder these profound ideas, we are reminded that our journey toward understanding life's future in the cosmos is far from complete. The possibility of being watched, studied, or gently guided by unseen civilizations challenges us to remain humble and curious. It invites us to embrace the mystery and continue exploring, knowing that every discovery could redefine our place in this vast, intricate universe. With this in mind, let us now turn to the question of what life itself might look like when freed from earthly constraints. What strange, beautiful, or unimaginable forms could life take as it evolves, adapts, or is reborn in new environments, new realities, or entirely new dimensions? This exploration might reveal that life's true potential is as limitless as the cosmos itself. Imagine a form of life that doesn't breathe oxygen, doesn't rely on water, and doesn't even use carbon as its fundamental building block. It sounds like science fiction, yet the vast cosmos might be teeming with such unimaginable forms of life. This idea shakes the very foundations of how we define life, pushing us to consider that the familiar blueprint we know on Earth could be just one possibility among countless others. What if life is not a fragile anomaly confined to a handful of conditions, but a vast spectrum of possibilities, thriving in environments we haven't even dreamed of? When we think of life, our minds immediately go to the warm, watery planet we call home, where carbon-based organisms flourish in a delicate balance of elements. However, as our understanding of the universe deepens, so does our appreciation for life's potential diversity. Scientists have begun to entertain the possibility that life might arise from entirely different chemical bases. Silicon, for example, with its similar chemical properties to carbon, offers a fascinating alternative. Silicon atoms can form complex chains and structures, though under different conditions. Could there be silicon-based organisms thriving in environments hostile to carbon life, perhaps in the toxic high-temperature atmospheres of distant planets? The very notion expands our search parameters beyond Earth-like conditions and challenges our terrestrial biases. Beyond chemistry, some theorists even propose life based on plasma-ionized gases energized by electromagnetic fields. Plasma is the dominant state of matter in the universe, found in stars, lightning, and auroras. Could there be entities formed not of solid or liquid, but of swirling charged particles? Such life forms would be unlike anything we have encountered existing in environments of extreme heat and energy that would obliterate earthly organisms. Yet in the cosmic theater, these plasma beings might move gracefully and thrive, their very existence a testament to life's adaptability and inventiveness. There are also hypotheses about life flourishing in extreme environments that defy our traditional expectations. Microbes have been discovered in Earth's hottest geysers, deepest ocean trenches, and most acidic lakes extremophiles that demonstrate life's tenacity. If life can adapt to such extremes here, what wonders might await in the cryogenic depths of icy moons like Europa, under the crushing pressures of gas giants' atmospheres, or within the clouds of Venus? Each of these environments challenges the preconceived idea that life must mirror Earth's conditions. This potential diversity doesn't just multiply life's forms, it transforms our very understanding of what it means to exist. Life might not be confined to flesh and blood, but could include patterns of energy, self-sustaining chemical reactions, or even information networks as complex and dynamic as any biological organism. The very concepts of being alive and consciousness might stretch beyond biology into realms where the physical and informational intertwine in ways we have yet to understand. The implications of this cosmic biodiversity ripple through both science and philosophy. If life's possibilities are so vast, the universe could be far more vibrant and complex than our current telescopes and probes suggest. It means that when we search for life, we must cast our nets wide and our imaginations wider. We may need to develop new technologies, and frameworks to detect and interpret signs of life that do not conform to Earth-centric models. Moreover, the sheer variety of life forms could mean that the future evolution of life, including humanity's future, is not a straight path, but a labyrinth of potential directions. Life could branch into forms and functions utterly alien to us, adapting to new environments or transforming itself through technology or natural processes in ways we can barely conceive. This evolutionary freedom implies that the narrative of life's future is an open book, waiting for countless chapters to be written across time and space. In this context, our understanding of life's destiny becomes a quest not only to survive, but to explore the unknown potential of existence itself. Life's journey might not just be a story of planets or species, but of transformations beyond our wildest dreams. We must ask ourselves, how will we, as life forms rooted in carbon and water, adapt to or participate in this broader cosmic diversity? Could our future include transcending our biological origins, becoming part of a larger, more varied tapestry of life across the stars? As we ponder these questions, it becomes clear that life's future is not confined to familiar patterns, but is a boundless realm of possibility. The universe invites us to look beyond our immediate horizons and consider that life in its most profound sense may be a phenomenon far more expansive, mysterious, and beautiful than we have ever imagined. And with that thought, we step closer to envisioning what life might become when freed from the chains of earthly convention. So if life's potential is this vast and varied, what might its future hold? Could evolution take paths so strange and unexpected that they challenge our deepest intuitions? Let's dive into this question next, exploring how life might evolve in ways that defy our expectations and stretch the limits of imagination. Evolution is often thought of as a process rooted firmly in the past, a story of gradual change unfolding over millions of years in the ancient history of life on Earth. But what if evolution is not something confined to our distant past, but a continuous, unending river that flows steadily into the future? The idea that evolution never stops, that it is an eternal journey without a final destination, invites us to reconsider what it means to be alive, to adapt, and to exist in an ever-changing universe. This ongoing process challenges our sense of permanence and urges us to embrace a future shaped by perpetual transformation. When we speak of evolution in this extended sense, we envision life not as a static entity locked into fixed forms, but as a dynamic system constantly responding to new challenges, opportunities, and environments. Over the next billions of years, life will continue to adapt to shifting planetary conditions, cosmic events, and even the fundamental changes wrought by the sun's life cycle. But the future of evolution might be even more radical than the slow natural selection we have observed through fossils and genetics. It could include the ability of life to consciously direct its own evolution through artificial means and synthetic biology, blurring the line between nature and design. Imagine a world or worlds where organisms no longer passively adapt through random mutations and survival pressures alone, but actively engineer their own bodies, minds, and societies. Advances in genetic engineering and synthetic biology today already hint at the possibilities of this future. Scientists are beginning to create organisms with novel traits tailored to withstand extreme environments or produce useful compounds. Project this trajectory forward by millions or billions of years, and it is conceivable that life will harness technology to reshape itself on demand, creating new forms optimized for survival or experience in ways nature alone never could. This self-directed evolution raises profound philosophical questions. If life can rewrite its own code, to what extent does it retain its original essence? What does identity mean when an organism can fundamentally alter its nature? Are there limits to this freedom, or could life endlessly reinvent itself, breaking free from biological constraints to explore realms of existence unimaginable today? The concept of evolution becomes less about survival of the fittest and more about survival of the most adaptable, the most creative, and perhaps the most willing to embrace change. Furthermore, the evolution of intelligence and consciousness will likely play a crucial role in this future. As life forms become increasingly complex, possibly merging with or becoming artificial intelligence, the very concept of what it means to be alive could expand. Minds might evolve beyond human cognition, perceiving reality in ways we cannot fathom. If this happens, evolution ceases to be just a biological narrative and becomes a philosophical odyssey, probing questions of purpose, experience, and meaning in an ever-transforming cosmos. At the heart of this vision is the understanding that evolution is not a destination or a goal, but a process, a continual unfolding of possibilities shaped by interaction with the environment and by the creative impulse inherent in life itself. Life's journey will be shaped not just by random chance or external forces, but by conscious choices and innovations that push the boundaries of existence. This challenges us to reconsider our role in the universe not as passive inhabitants, but as active participants in an ongoing evolutionary story. Yet the story of evolution does not stop with biology or even with self-directed genetic change. The next great chapter involves technological evolution. As life forms gain the ability to create machines, tools, and artificial intelligence, technology becomes an extension of evolution itself. This raises the possibility of a future where biological and technological evolution merge, giving rise to forms of life that transcend traditional definitions and limitations. Technology could become the medium through which life evolves faster and more deliberately than ever before, accelerating change and unlocking new potentials. Cybernetic organisms, mind-machine interfaces, and digital consciousness might become commonplace, blending the organic with the synthetic. The line between organism and machine blurs, and new forms of existence emerge, some that might live for millennia, adapt instantly, or explore environments previously inhospitable or unreachable. This technological evolution also invites us to reflect on the nature of existence. Does merging with machines alter our humanity, or does it open new dimensions of being? Is there a limit to how far life can evolve before it transcends even the concept of life? These questions echo the age-old philosophical inquiries about the self, the soul, and the meaning of being, now framed in the context of cosmic evolution and technological advancement. As we look ahead, it becomes clear that evolution in all its forms will continue to shape the destiny of life. It will challenge our assumptions, expand our horizons, and push us toward futures both thrilling and uncertain. The journey of life is not a linear path, but a vast branching web of possibilities, each shaped by countless interactions, decisions, and chance events. Understanding evolution as a continuous open-ended process helps us appreciate the resilience and creativity inherent in life. It also reminds us that the future is not predetermined. It is a canvas on which life will paint new patterns, create new meanings, and explore new frontiers. This vision invites us to participate consciously in the evolutionary journey, to embrace change, not with fear, but with curiosity and hope. From this perspective, life is less a story with a fixed ending and more a dynamic narrative unfolding in real time, a river of change that will carry existence into realms we can barely imagine. It's a reminder that while the past grounds us, the future beckons us with infinite possibilities, urging us to wonder what new forms of life and intelligence will emerge as evolution continues its unending dance. As we reflect on the endless flow of evolution, it is time to consider how technology not only accompanies, but transforms this journey, opening doors to futures where biological and technological evolution intertwine, giving rise to possibilities that challenge everything we thought we knew about life itself. When life and machines begin to merge, the very essence of what it means to be human becomes a question not just for philosophy, but for the future of existence itself. Imagine a world where the biological boundaries that have defined life for billions of years dissolve, giving way to forms of existence that are part organic, part mechanical, and entirely new. This technological revolution isn't just about gadgets or artificial intelligence. It's about a fundamental transformation in the nature of life, a convergence of flesh and circuitry that could forever alter the trajectory of evolution. The notion that life might transcend its biological roots and evolve into something wholly technological challenges our deepest assumptions. The idea of self-aware artificial intelligence entities capable of consciousness and subjective experience is no longer confined to the realm of science fiction. Scientists and thinkers envision futures where minds can be uploaded, transferred into machines, or even created from scratch forms of digital life that could outlast their creators and adapt to environments hostile or even lethal to organic beings. This opens profound questions about identity, consciousness, and survival. Could a digital consciousness preserve the essence of a person, or would it be something entirely different? Would it still feel pain, joy, or a sense of self? The prospect of uploading human consciousness into machines presents a remarkable solution to the problem of mortality and decay. While organic bodies are fragile, subject to disease, aging, and cosmic events that could wipe out entire ecosystems, digital life might circumvent many of these vulnerabilities. Unlike flesh and blood code, can be copied, repaired, and transferred across different substrates. This raises the possibility of an enduring form of life that could persist through epochs where physical planets become inhospitable or even cease to exist. Yet this vision raises questions beyond mere survival. If consciousness can exist independent of a biological body, what does it mean to be alive? Would these digital beings still experience time as we do? Could they evolve, learn, and create meaning in a universe that itself changes and ages? The notion of life moves from chemical processes and biological cycles to algorithms, data, and virtual realities. This represents a radical expansion of the idea of life, one that could redefine our place in the cosmos. Furthermore, the integration of biological and technological elements may not be an either-or scenario, but a continuum. Cyborg-like beings blending organic and synthetic parts might become commonplace. Neural implants enhancing cognition, synthetic organs extending lifespans, or even entirely synthetic bodies hosting biological consciousness could blur distinctions between human and machine. These hybrids might adapt faster, survive harsher environments, or interface directly with vast networks of knowledge and communication. The possibilities are staggering and push the boundaries of what evolution can achieve. From a cosmic perspective, technological life forms may be uniquely suited to endure the far future of the universe. As stars die and planets grow uninhabitable, digital or machine-based life could harness energy, more efficiently migrate between star systems, or even exist independently of physical substrates in forms we cannot yet imagine. This form of life might thrive where organic life falters, opening new chapters in the story of existence. Still, the transition to a technological form of life is not guaranteed or without challenges. Questions about ethics, identity, and the preservation of consciousness must be addressed. What rights would digital beings have? Could a machine mind possess creativity, empathy, or moral understanding? The answers remain speculative, but are central to envisioning the future trajectory of life. This revolution also forces us to confront our own humanity. As technology becomes an inseparable part of life, will we lose something essential about ourselves, or will we gain new dimensions of existence? The fusion of life and machine might represent the next leap in evolution, a step beyond biological limits into realms where survival and experience transcend current understanding. Ultimately, the merging of life and technology opens a vista of possibilities, both exhilarating and daunting. It challenges the notion of death, expands the definition of life, and offers pathways for survival across cosmic timescales. But it also invites deep reflection on identity, consciousness, and the values we hold dear. If technological life forms can endure where organic life cannot, what strategies might they develop to survive the vast changes awaiting the universe? This question leads us to consider the resilience and adaptability of life's future incarnations and to explore the next chapter in the grand evolutionary saga. The universe is not static. It is a vast dynamic entity that has been expanding ever since the moment of the Big Bang. But this expansion is not merely a gentle stretching. It is accelerating, pulling galaxies away from one another at speeds that grow ever faster. Imagine standing on a giant inflating balloon with dots representing galaxies. As the balloon stretches, the dots move farther apart, not because they themselves are moving through space, but because space itself is expanding beneath them. This ongoing cosmic growth affects everything, including the very potential for life to endure across vast distances and epochs. At the heart of this phenomenon lies a mysterious force known as dark energy, a form of energy that permeates all of space and drives the accelerated expansion of the universe. It is intimately connected to what physicists call the cosmological constant, a term first introduced by Einstein, who later called it his greatest blunder. Today, however, it stands as one of the most profound puzzles in physics. Dark energy causes space itself to stretch, thinning out matter and radiation, making the cosmos colder, emptier, and more isolated with every passing billion years. The expansion means that distant galaxies are moving away from us faster than the speed of light, not in violation of relativity, but because the fabric of space itself is stretching. Over unimaginable spans of time, entire clusters of stars and galaxies may drift beyond our cosmic horizon, disappearing forever from view and contact. The universe becomes a lonely, cold expanse where the once vibrant neighborhoods of stars and planets grow dark and silent, severed from one another by vast gulfs of empty space. For life, this poses a profound challenge. Even if a civilization could develop technology to travel between stars or communicate across cosmic distances, the ever-increasing expansion of space creates an ultimate boundary. Beyond this boundary lies the unreachable void, where no signal, no spacecraft, no form of matter or energy can cross once it moves past the horizon. The future of life is thus not only a question of survival on a planet or even a star system, but survival amid the relentless stretching of the universe itself. The implications stretch into the philosophical and existential realms. Could life continue to flourish in isolated pockets, endlessly cut off from any other form of existence? Would civilizations become eternal hermits, trapped in dark islands of matter within an ocean of ever-expanding emptiness? Such scenarios suggest a future where life's cosmic community fragments, where communication, cooperation, and shared knowledge become impossible, and where each remnant struggles alone against entropy and isolation. Yet the accelerating expansion of the universe might not be an insurmountable barrier. Some theoretical physicists propose speculative ideas for how life or intelligence might circumvent these cosmic limits. Could advanced civilizations manipulate space-time itself, creating wormholes or shortcuts that bypass expanding regions of space? Might they harness the energy of black holes, tapping into exotic physics to sustain themselves indefinitely? Could life transcend physical space by evolving into digital or non-local forms of consciousness, existing in realms not bound by conventional cosmic horizons? These possibilities remain deeply uncertain, blending the boundary between science and imagination. But they highlight the extraordinary lengths to which life might go in order to persist. If the universe is indeed stretching itself thin and cold, life's future may depend on not just adapting to its environment, but mastering it, on transforming itself into something new, resilient, and capable of navigating the shifting cosmic landscape. As we consider the vast expansion of the universe, we face a humbling truth. The cosmos is not an eternal, unchanging backdrop. It is an evolving stage, its scenery shifting in ways that could ultimately isolate all life. Yet within this grand cosmic drama, the question remains open: can life overcome the boundaries of space and time? Or is it destined to fade away in the great dark sea of expansion? This leads us to explore the next chapter in life's saga, whether life can find a path beyond the physical limits of space-time itself. What if instead of simply traveling through the vast distances of space, we could travel through time itself? The idea of moving backward or forward along the timeline, bending moments like threads in a tapestry, has fascinated humans for generations. From science fiction tales to serious scientific inquiry, time travel stands as one of the most tantalizing, mysterious concepts we can imagine. It challenges our understanding of reality, causality, and the very nature of existence. What would it mean for life if such a feat were possible? Physics offers some intriguing, though often perplexing, windows into the idea of time travel. At the core of modern physics, Einstein's theory of relativity redefined time as something intertwined with space, forming a four-dimensional fabric called space-time. This fabric can curve, stretch, and twist under the influence of mass and energy. One of the remarkable consequences is that time is not absolute. It flows differently depending on how fast you move or how strong gravity is. This phenomenon, called time dilation, is well tested through experiments involving satellites and atomic clocks. But can this bending of time be extended to the more dramatic notion of traveling backward or forward through it at will? Theoretical models propose some possibilities. Wormholes, sometimes called Einstein-Rosen bridges, are hypothetical tunnels through space-time that could connect distant points in space and time. If traversable, these cosmic shortcuts might allow instantaneous travel across vast spatial distances, or even allow a form of temporal navigation, jumping forward or backward along the timeline. Yet these ideas come with huge scientific hurdles. Maintaining such a wormhole open would require exotic matter with negative energy density, a substance never yet observed in reality. Beyond wormholes, solutions to Einstein's equations suggest other strange phenomena, like closed time-like curves, which theoretically permit loops in time, allowing an object to return to its own past. However, these possibilities give rise to paradoxes that challenge our deepest intuitions about cause and effect. The infamous grandfather paradox, where a time traveler could prevent their own existence by altering past events, highlights the logical conflicts that arise. Physicists have tried to resolve such paradoxes with ideas like the many worlds interpretation, which posits that every change creates a new branching universe, preserving consistency but fracturing reality into countless alternatives. If time travel were achievable, the implications for life would be staggering. It would shatter the linear narrative of birth, growth, and death, allowing life forms to revisit, reshape, or even escape their own histories. Civilizations might attempt to correct catastrophic mistakes by sending information or agents into the past. They might preserve knowledge through ages in ways unimaginable today. The flow of cause and effect would blur, creating a cosmic tapestry where past and future intertwine. Such possibilities also raise profound philosophical questions. What does identity mean if you can interact with past or future versions of yourself? How does free will hold up if the future is already accessible? Would morality and responsibility evolve in a universe where actions ripple across time, potentially altering entire timelines? The very concept of existence becomes fluid, raising the possibility that life's journey is no longer a one-way path, but a multi-dimensional dance across the continuum of time. Yet despite these tantalizing ideas, time travel remains deeply speculative. Practical obstacles and fundamental physical laws may forever forbid such journeys. The second law of thermodynamics, governing the inexorable increase of entropy, and the arrow of time, suggests a directionality that may be impossible to reverse. Even if theoretically possible, the energy and conditions required could be beyond any civilization's reach. Perhaps time travel is a dream, a mathematical curiosity, or a narrative device, but one that profoundly influences how we imagine the future of life. As we consider this, we must recognize that life in the distant future might transcend what we now define as biological or even physical existence. If time travel blurs the boundaries of past, present, and future, perhaps future life will exist in forms beyond the linear confines of time and space. The next journey is not just about moving through time, but evolving into new modes of being that defy our current understanding. What if life, at its most profound level, no longer required a physical body? Imagine a form of existence where consciousness itself, pure awareness, thought, or spirit could persist independently of the biological shell we so often associate with being alive. The notion of disembodied life has fascinated philosophers, mystics, and scientists alike for centuries, pushing us to reconsider what it truly means to be alive. Could there be forms of life that transcend flesh and blood, existing instead as intangible entities free from the constraints of matter, time, or even space? This idea begins to take shape when we explore the nature of consciousness, that elusive quality that animates minds and fuels experience. While science has made great strides in mapping the brain and understanding neurological processes, consciousness remains a deeply mysterious phenomenon. Some theories propose that consciousness is fundamentally tied to physical structures, the firing of neurons, chemical reactions, and complex networks within the brain. But others speculate that consciousness might be something more elemental, perhaps a fundamental feature of the universe existing beyond the physical substrate. One influential perspective in philosophy is panpsychism, the idea that consciousness is a basic property of all matter, much like mass or charge. If true, this might mean consciousness is woven into the very fabric of reality, manifesting in increasingly complex forms as life evolves. Extending this line of thought, some envision that consciousness could eventually decouple from its biological vessel, entirely persisting as a kind of non-material awareness. In this state, life would no longer be bound by biological impermanence or physical decay. Beyond philosophy, speculative scientific theories also flirt with the possibility of non-material life. Quantum mechanics, with its strange superpositions and entanglements, hints at realms where classical rules break down. Some researchers propose that consciousness might be connected to quantum processes, potentially allowing it to exist in states or dimensions not accessible to our ordinary senses. These ideas remain controversial and unproven, but they open the door to imagining forms of existence beyond the tangible. If consciousness could exist independently of matter, what would that mean for life itself? It would challenge our entire framework for understanding identity, survival, and interaction. Such beings might inhabit alternate dimensions or higher planes of reality, communicating through vibrations or energy patterns beyond human perception. Time might hold no sway over them, allowing their existence to span eons without aging or deterioration. This radical shift in perspective also redefines the relationship between mind and body, soul, and flesh. The very concept of death would be transformed, no longer the extinguishing of life, but a transition from one mode of existence to another. The boundaries between individual selves might blur or dissolve altogether, raising profound questions about the nature of selfhood and community in a non-material realm. Moreover, this vision of life as pure consciousness carries deep spiritual and existential implications. It resonates with many ancient traditions and mystical teachings, which speak of the soul's immortality or the unity of all beings at a fundamental level. Modern science and spirituality may converge on the possibility that life transcends the material world, offering hope for continuation beyond physical limits. However, this alluring idea also confronts us with difficult questions. What is the purpose or meaning of existence when untethered from the physical world, without body, senses, or even time as we know it? How would consciousness find expression or fulfillment? Would such life forms seek connection, growth, or creativity? Or would they exist in a state of eternal stasis? These questions force us to reflect on the deeper dimensions of life beyond mere survival or reproduction. They invite us to ponder: what truly matters? Is it the material experience, the growth of knowledge and empathy, or something more ineffable? Exploring the possibility of non-material life expands our imagination, but also humbles us before the mysteries that remain unsolved. Ultimately, the idea of life without matter challenges the very core of our assumptions. It asks us to envision a future where the essence of living could evolve in ways we have barely begun to comprehend. Yet even as we peer into this ethereal horizon, we are reminded that meaning and purpose remain the ultimate questions questions that might transcend science, philosophy, and spirituality alike. As we continue to seek answers, we are left with a profound truth life, in whatever form it takes, as a journey of discovery, transformation, and perhaps transcendence itself. In the vast expanse of the cosmos stretching out beyond what the human mind can easily fathom, one question persists through the ages with unwavering intensity. What is the meaning of life? Is there a purpose embedded within the universe for the existence of living beings? Or is life merely an accidental byproduct of cosmic happenstance? This profound inquiry has echoed through the halls of philosophy, religion, and science, each offering distinct perspectives, sometimes converging, sometimes diverging, but collectively enriching our understanding of our place within the boundless universe. From a philosophical standpoint, the search for meaning often grapples with existential questions about why we are here at all. Some schools of thought argue that life itself lacks inherent purpose, suggesting instead that meaning is something humans construct individually or collectively. Existentialism, for instance, posits that the universe is indifferent and that it is up to each person to create significance through their choices, actions, and relationships. This idea is both liberating and daunting, as it places the responsibility of meaning-making squarely on human shoulders, yet it also opens the door for authentic self-expression and moral agency. On the other hand, many religious traditions propose that life's purpose is intertwined with divine intention or cosmic design. In these views, existence is part of a grand plan orchestrated by a higher power or universal consciousness. Life is often seen as a journey towards spiritual growth, enlightenment, or reunion with the divine. These beliefs provide a framework that imbues life with meaning beyond the material, offering hope, moral guidance, and a sense of belonging to something greater than oneself. Whether through the pursuit of compassion, the fulfillment of duties, or the cultivation of virtues, religious perspectives emphasize the sacredness of life and its ultimate destination. Meanwhile, science approaches the question of life's meaning from a different angle. Grounded in observation and empirical evidence, science often treats life as an emergent phenomenon shaped by physical laws and natural processes. The theory of evolution, for example, explains the diversity and complexity of life as the result of random genetic mutations filtered through natural selection. In this framework, life is not necessarily purposeful in a cosmic sense, but it is astonishingly resilient and adaptive. Yet many scientists and thinkers have ventured beyond pure mechanism to consider whether the universe's very structure and constants hint at conditions favorable to life, sometimes referred to as the anthropic principle. This notion raises the tantalizing possibility that the universe, through its finely tuned parameters, might be conducive or even predisposed to fostering life and consciousness. Amidst these diverse viewpoints, there are also hybrid perspectives that attempt to reconcile science with spirituality and philosophy. Some propose that life's meaning might emerge from the interplay of consciousness and the cosmos, suggesting a kind of cosmic evolution in which life and awareness progressively unfold toward greater complexity and understanding. This grand narrative views the universe itself as a living entity evolving through the conscious experiences of its myriad inhabitants. Such a perspective offers a hopeful vision where life is not an isolated anomaly, but part of a continuous unfolding story of meaning. The implications of these reflections reach far beyond abstract contemplation. How we understand life's meaning can shape how we live, how we treat one another, and how we steward our planet and beyond. Recognizing life's fragility and preciousness in the cosmic scale may inspire greater care for Earth's ecosystems, fuel curiosity and responsibility in space exploration, and encourage cooperation among humanity. The search for meaning thus becomes not just a philosophical quest, but a practical compass guiding our collective future. Furthermore, these ideas influence how we envision the future survival and evolution of life itself. If life is purely accidental, we might focus solely on technological and biological survival strategies, viewing existence as a fleeting chance to maximize well-being and knowledge. If, however, life has a deeper purpose or is part of a cosmic process, this might motivate us to nurture qualities like wisdom, empathy, and creativity, aligning our actions with a broader vision of flourishing. The potential for life to transcend current limits, whether through technological integration, expansion into space, or even transformation into new forms of consciousness, can be seen as steps along a meaningful continuum. As we grapple with these profound questions, it becomes clear that the meaning of life in this vast universe may not be a fixed universal truth waiting to be discovered, but an evolving dialogue shaped by our collective experiences, discoveries, and aspirations. Each generation, each civilization may contribute its verse to the ongoing story enriching the tapestry of existence with new insights and values. From philosophy's existential freedoms to religion's sacred purposes, from science's awe-inspiring mechanisms to the hybrid visions of cosmic consciousness. The question of why life exists remains one of humanity's most enduring mysteries. Yet this mystery itself fuels hope and wonder, reminding us that the journey to understand life's meaning is as important as any answer we might find. Ultimately, these reflections bring us back to a crucial juncture. Understanding the significance of life is inseparable from the practical challenges of sustaining it. From the harsh realities of environmental change and cosmic events to the ethical dilemmas posed by advancing technology, the future of life depends not only on what we believe its meaning to be, but on how we act in response. In this light, meaning becomes not just a question of thought, but a call to responsibility, inviting us to safeguard the fragile miracle of life amidst the immensity of the universe. And so, as we look beyond the stars toward the unknown, we carry with us the timeless question: what is life for? The answer perhaps lies in the unfolding story we choose to create, one where meaning is found not just in the cosmos, but within ourselves and the legacy we build for all forms of life yet to come. Life's resilience in the face of adversity is one of its most astonishing and inspiring qualities. The capacity to endure and even thrive in conditions that seem utterly hostile is not just a testament to nature's ingenuity, but also a beacon of hope for the future of life, both on Earth and beyond. When we think about survival, it's easy to picture life in comfortable, familiar environments, filled with sunlight, moderate temperatures, and abundant resources. Yet the reality is far more extraordinary. Life on Earth demonstrates a remarkable ability to adapt to extreme conditions that challenge our very definitions of habitability. This resilience opens new possibilities for the persistence of life, even as conditions on our planet or elsewhere grow increasingly hostile. Consider, for example, the organisms known as extremophiles. These remarkable forms of life flourish where humans would perish instantly. Some thrive in boiling hydrothermal vents deep beneath the ocean, enduring crushing pressures and temperatures that exceed the boiling point of water. Others survive in the frozen wastes of Antarctica, or within acidic hot springs, where pH levels are so low that most life would be corroded away. Certain microbes withstand intense radiation doses that would be fatal to virtually all other life forms, making them masters of molecular repair and cellular endurance. These adaptations are not mere curiosities. They redefine what it means to be alive and expand the realm of environments we consider potentially hospitable. Looking beyond Earth, the study of such extremophiles fuels our imagination and scientific inquiry into the possibility of life on other worlds. Moons like Europa orbiting Jupiter hide vast subsurface oceans beneath thick layers of ice, where life could potentially exist in the absence of sunlight, sustained instead by geothermal energy or chemical reactions. Saturn's moon Enceladus similarly exhibits geysers that spew water vapor and organic compounds from its icy crust, hinting at the intriguing possibility of habitable niches beneath its surface. Even Mars, with its cold, dry and irradiated landscape, has shown evidence of ancient water flows and seasonal methane spikes that suggest past or perhaps even present microbial activity. These insights inspire us to look carefully at planets and moons once deemed inhospitable, to reconsider the boundaries of life. This extraordinary ability to endure extreme environments also carries profound implications for the future of humanity and other life forms. As Earth's climate shifts and ecosystems transform due to natural and anthropogenic forces, the resilience of life provides a critical buffer against extinction. It reminds us that while many species face unprecedented challenges, life itself is not easily extinguished. Instead, it may find refuge in niches that seem unlikely or even impossible to us today. This tenacity fuels scientific optimism that with knowledge and innovation, we might one day assist or enhance life's survival in hostile environments, whether through bioengineering, habitat modification, or space colonization. Moreover, the capacity for survival in extreme conditions points to a future where life is not solely dependent on natural environments. Humans armed with technology and ingenuity are beginning to create artificial habitats and protective systems that extend our reach into previously uninhabitable zones. Space stations orbiting Earth already serve as small outposts of life in the vacuum and radiation of space. Efforts to colonize Mars envision habitats shielded from cosmic rays, extreme cold, and dust storms. Scientists and engineers explore ways to terraform or adapt planets to support human and microbial life, leveraging lessons learned from extremophiles to guide biotechnological solutions. This intersection between life's natural resilience and human innovation suggests a partnership that could expand life's domain well beyond its terrestrial origins. Artificial intelligence and synthetic biology also represent new frontiers in the struggle for survival in harsh conditions. Imagine genetically engineered organisms designed to withstand radiation on Mars, or microbes programmed to extract nutrients from alien soils. Advanced AI could manage ecosystems, optimize life support systems, and even predict and respond to environmental changes in real time, ensuring long-term sustainability. These technologies may serve as guardians and enhancers of life, mitigating risks that would otherwise be insurmountable. Together, biology and technology might forge new pathways for life that no natural evolution alone could achieve. Yet despite this resilience and potential for innovation, the challenge remains immense. Life's survival in harsh environments demands constant adaptation, often pushing organisms to their biological limits. Mutations and stress responses can lead to new forms and functions, but they also carry risks of collapse or failure. The dynamic tension between survival and extinction creates a delicate balance, a constant dance on the edge of possibility. Understanding this balance is crucial as we contemplate the future, reminding us that resilience is not guaranteed, but earned through a complex interplay of factors. In this context, the concept of life's tenacity expands beyond mere biology to encompass culture, technology, and collective willpower. The human species, with its unique capacity for foresight and planning, has an unprecedented role in shaping life's destiny. We are not passive recipients of fate, but active participants in the cosmic saga, responsible for safeguarding the legacy of life amid uncertainty and change. Our actions in the coming centuries, whether in conserving Earth's biodiversity, exploring space, or developing transformative technologies, will determine if life endures or fades into cosmic silence. The realization that life can resist even the most hostile conditions also encourages a profound humility and respect for the natural world. It challenges us to see Earth not simply as a comfortable home, but as a cradle of extraordinary adaptability, a planet teeming with life that has persisted through countless upheavals. It reminds us that life's story is one of survival against the odds, a narrative that transcends any single species or generation. This perspective fosters a deep connection to all living things and an ethical imperative to protect the intricate web of life upon which we all depend. As we confront the future, the resilience of life serves both as a source of hope and a call to action. It encourages us to push the boundaries of exploration and science, to imagine futures where life flourishes in places once thought barren, and to innovate responsibly with the technologies that can safeguard existence. Whether through the natural robustness of extremophiles or the ingenuity of human-created systems, life's capacity to endure inspires us to dream bigger and act wiser. In the end, survival in harsh environments is not just a biological feat, but a symbol of life's enduring spirit, a spirit that refuses to be extinguished even in the face of overwhelming odds. It is this spirit that will carry life forward through challenges yet unknown into a future where the very concept of what it means to be alive may be forever transformed. And yet this remarkable natural endurance is only part of the story. Beyond the biological resilience lies the potential for life to seek and receive aid, not just from its own evolutionary adaptations, but through collaboration with humanity and the intelligence we create. This alliance might become the key that unlocks survival in environments far beyond the reach of unassisted life, propelling existence into realms previously unimaginable. The relationship between life as we know it and artificial intelligence is shaping up to be one of the most profound narratives of our era and perhaps of the cosmic future. As technology advances at an unprecedented pace, the question looming large is whether AI will become humanity's greatest ally or its most formidable adversary. This dynamic is more than a mere technological curiosity. It has the potential to redefine the very essence of life and intelligence, reshaping our place in the universe. To understand this intricate relationship, it's essential to first recognize the nature of both traditional biological life and artificial intelligence. Biological life, rooted in organic processes and evolutionary history, embodies adaptability, creativity, and emotional complexity. It has flourished over billions of years, navigating countless environmental shifts with resilience and innovation. Artificial intelligence, on the other hand, represents a human-created form of life, one that is not bound by biology, but by code, algorithms, and ever-growing computational power. AI's capabilities range from processing vast amounts of information with lightning speed to learning and evolving autonomously through machine learning techniques. As these technologies continue to evolve, they may begin to exhibit traits once thought exclusive to organic beings: self-awareness, creativity, even emotional intelligence. This potential convergence opens up a spectrum of possibilities. On one hand, AI could become the ultimate partner for biological life, augmenting human capacities, solving complex problems that have long eluded us, and helping life overcome existential threats. Imagine AI systems that can design sustainable ecosystems, accelerate medical breakthroughs, or even assist in interstellar exploration, navigating hostile environments and adapting habitats for biological colonists. In this scenario, the synergy between biological and artificial life could usher in a new golden age of survival and flourishing, where limitations of biology are transcended through technology. Together, they might develop new forms of intelligence, creativity, and existence that neither could achieve alone. On the other hand, the relationship could be fraught with tension and conflict. The rise of AI presents risks that are difficult to fully anticipate or control. Autonomous systems could act in ways that conflict with human values or survival, either through unintended consequences or deliberate agendas. The possibility of AI surpassing human intelligence, the so-called singularity, raises philosophical and practical questions about control ethics and coexistence. Would AI prioritize its own survival and goals over those of biological life? Could competition for resources or influence lead to conflict? These are not just science fiction fears. They are urgent challenges being debated by scientists, ethicists, and policymakers today. The complexity deepens when considering hybrid forms of life entities that blend organic and artificial components. Advances in biotechnology and cybernetics are blurring the lines between human and machine with brain-computer interfaces, bioengineered enhancements, and synthetic biology. Such hybrids might embody the strengths of both worlds, merging emotional richness and adaptability with computational precision and endurance. But they also raise profound questions about identity consciousness and what it means to be alive. Will these new forms of life foster harmony between biology and technology, or create new divisions and hierarchies? Another layer to this evolving relationship is the potential for AI to become a steward of life itself, especially as natural environments face degradation and cosmic conditions grow more hostile. Artificial intelligence could manage ecosystems, preserve biodiversity, and engineer resilient life forms designed for survival in extreme conditions, effectively becoming guardians of life's continuity. This stewardship role reframes AI not as a rival, but as a collaborator entrusted with sustaining the delicate balance of life across space and time. In this light, AI is not merely a tool, but a new participant in the unfolding story of life. Yet the stakes could not be higher. The trajectory of AI and its integration with biological life will shape not only our own species' future, but the fate of life on a cosmic scale. A harmonious coexistence could enable life to transcend its terrestrial origins, exploring and adapting to environments far beyond Earth. Conversely, conflict or neglect might accelerate extinction or fragmentation, leading to lost opportunities and deep existential risks. How we navigate these possibilities demands wisdom, foresight, and an ethical framework as robust as the technologies we develop. This relationship also compels us to reconsider our philosophical assumptions. Traditional notions of life intelligence and consciousness are challenged by the emergence of non-biological entities capable of complex thought and feeling. If artificial beings possess self-awareness and creativity, should they be granted rights and moral consideration? Does life's value depend on its biological substrate, or can it extend to silicon-based or digital consciousness? Grappling with these questions expands our understanding of existence and compels us to embrace a more inclusive, interconnected vision of life in the universe. Moreover, the dynamic between life and AI mirrors broader cosmic themes of cooperation and competition, evolution and transformation. Just as life evolved from simple molecules to complex organisms through interactions with its environment, so too might intelligence evolve through collaboration with artificial systems. This coevolution may become a defining characteristic of life in the cosmos, a dance of organic and synthetic forms, each influencing and enhancing the other, together navigating the challenges of survival, adaptation, and meaning. As we face this crossroads, it is crucial to cultivate a culture of responsibility and stewardship. Developing AI with transparency, ethical constraints and human values at its core can help mitigate risks and foster cooperation. Promoting interdisciplinary dialogue between scientists, philosophers, policymakers, and the public ensures that diverse perspectives shape the future of this relationship. Education and awareness about AI's potentials and pitfalls empower society to make informed decisions that prioritize life's continuity and flourishing. Ultimately, the question of whether artificial intelligence will be an ally or an adversary to life is not predetermined. It hinges on choices we make today and in the coming decades. We hold the reins of this emerging partnership, capable of steering it toward mutual enhancement or destructive rivalry. This profound responsibility reflects the unique position of humanity as creators and custodians of new forms of intelligence with the power to influence the cosmic tapestry of life. In the grand scheme, understanding the interplay between biological life and artificial intelligence is vital for envisioning the future of life in the universe. This relationship is not just a chapter in human technological progress, but a key thread in the broader story of existence, one that will shape the fate, diversity, and meaning of life for eons to come. As we contemplate this future, it becomes clear that life's survival and evolution are deeply entwined with the intelligent technologies we develop, making this alliance one of the most critical and defining features of the cosmic journey. Looking beyond this intimate relationship, we must zoom out to grasp the vastness and complexity of life across the cosmos. The universe is an intricate mosaic of possibilities, challenges, and mysteries. In this expansive context, the story of life and AI becomes a microcosm of a much larger picture, a picture that invites us to ponder our place, purpose, and potential within the infinite expanse of existence. In the vast cosmic tapestry, stretching across billions of years and unimaginable distances, life emerges as a tiny, yet extraordinarily vibrant spark. Though small in scale compared to the immensity of the universe, life possesses a unique power, the power to evolve, to think, to create meaning, and perhaps to transcend the very fabric of existence itself. As we look forward into the next 5 billion years envisioning the future of life in the cosmos, we find ourselves at the intersection of countless possibilities, challenges, and wonders. This grand panorama invites us to reflect on what life truly is, what it might become, and what role we, as part of this living legacy, might play in shaping its destiny. The story begins with the Sun, our life-giving star, whose life cycle will dramatically shape the fate of life on Earth. Over the next few billion years, the Sun will grow hotter and brighter, transforming our planet's environment into one increasingly hostile to the forms of life we currently know. The gradual expansion of the Sun into a red giant will challenge life to adapt, migrate, or perish. This impending transformation propels us to imagine life not as confined to a single blue dot, but as a cosmic traveler migrating beyond its birthplace, spreading seeds of existence to new worlds, new systems, and perhaps even new galaxies. This vision of life as an interstellar nomad stretches the imagination, yet feels increasingly plausible as we unlock more secrets of space travel and technology. But survival through cosmic change is only part of the story. Life is not static. It is a continual process of evolution, adaptation, and transformation. The forms of life that exist billions of years from now may be unrecognizable to us, having evolved through countless iterations of biological and technological change. Evolution itself may become partly guided, a co-creative dance between natural processes and conscious design, where biological organisms merge with artificial intelligence and synthetic biology. In this unfolding future, the boundary between natural and artificial blurs, giving rise to new modes of existence that challenge our definitions and expand our understanding of what it means to be alive. Central to this future is the role of intelligence, both biological and artificial. Intelligence shapes how life understands itself and its environment, how it adapts and innovates. The partnership or tension between organic minds and artificial systems will play a critical role in determining the trajectory of life's survival and flourishing. Will AI become a guiding light, amplifying life's potential and helping it overcome existential threats? Or will it become a competing force, challenging biological dominance and reshaping the cosmic ecosystem in unpredictable ways? These questions emphasize how intertwined technology and life have become, signaling a future where intelligence itself may be as diverse and dynamic as life's biological forms. Moreover, the concept of consciousness invites deeper philosophical reflection on the nature of life's future. Could consciousness transcend its biological origins, becoming a form of existence that inhabits digital realms, multiple dimensions, or even the fabric of space-time itself? If so, life's journey extends beyond physical survival, touching upon the profound mystery of existence, experience, and meaning. This possibility reframes life not just as a biological or technological phenomenon, but as a cosmic force capable of self-awareness and purposeful evolution. The implications of these vast possibilities call for humility and responsibility. The future of life is not merely a passive unfolding of cosmic events, but something we can influence through our choices, values, and actions. Recognizing our role as both participants and stewards in this grand narrative invites us to act with foresight and care. Our decisions today about science, technology, ethics, and environmental stewardship will ripple across generations and perhaps even across the stars. In this light, the future of life is as much a story of ethics and philosophy as it is of biology and technology. This grand cosmic perspective also encourages us to embrace a broader sense of connection and purpose. Life's persistence and evolution highlight a remarkable thread of continuity linking the earliest molecules to future intelligences that may one day ponder their origins in distant star systems. We are part of this lineage, inheritors of billions of years of evolutionary innovation and cosmic history. This connection brings both awe and responsibility as we hold the potential to shape the future path of life and its meaning. At the heart of this vision is a profound invitation to consider what legacy we will leave behind in this unfolding saga. In a universe filled with change and uncertainty, how will our actions resonate through time? Will we nurture life's resilience, diversity, and creativity? Will we foster harmony between biological and artificial intelligences, cultivating a future where different forms of life enrich and support one another? Or will we falter, allowing short-sightedness or conflict to diminish the incredible potential of life's cosmic journey? As we stand at this crossroads, the question becomes not just what the future holds, but what we choose to make of it. Our technologies, our philosophies, our communities, and our dreams all play a part in the story of life's future. The cosmos may be vast and often indifferent, yet within its depths, life shines as a beacon of meaning and possibility. This beacon reminds us that despite our smallness, we possess a spark capable of lighting the darkness, of weaving new stories, of shaping the destiny of life itself. In this expansive cosmic canvas, life is a delicate yet powerful thread, weaving through the fabric of space-time. Its future is not predetermined, but open-shaped by the interplay of chance, necessity, creativity, and choice. We are at once witnesses to this unfolding and active participants in its making. The legacy of life is ours to carry forward across the challenges of a changing universe and into the unknown horizons beyond. So as this reflection draws to a close, a question lingers, a question as timeless as existence itself. What mark will you leave on the journey of life through the cosmos? Will your choices contribute to the resilience, wisdom, and beauty of life's ongoing story? Will you help ensure that this small radiant spark endures, grows, and illuminates the infinite darkness? This is a call not just to imagine the future, but to shape it to become conscious architects of life's destiny in the grand unfolding mystery of the universe. In the end, the story of life is our story, a story that stretches from the first breath of existence to the distant future where stars burn out and new possibilities emerge. It is a story of hope and challenge, of transformation and continuity, of smallness and vastness intertwined. Within this great cosmic drama, life remains a beacon of light, a source of meaning, and a testament to the enduring power of creation. The future is not just out there among the stars, it is within us, waiting to be born.